Hello, and welcome to Real Application Cluster Overview. My name is Steve Hamilton, and I will be your instructor for this module. We will look at the overview of what is an Oracle 12c cluster. We will describe Oracle's brand new 12c Flex ASM architecture, and look at the overall cluster characteristics and how it can be applied to an Oracle 12c environment as well as your business community. So first of all, what really is clustering? Specifically, how does Oracle define its clustering? Well, clustering is the ability to share resources. When we talk about a database clustered environment, we are sharing data files. Those would be things like your data files, your control files, your online redo log files. It is not sharing an instance. So real application clusters is supporting in the event of an instance failure. It is also designed to improve performance, and this would be in environments such as parallel queries. The overall purpose of clustering is to increase availability. So it really does two main things. First of all, it gives us the ability to share our resources, and those resources would be things like data files, control files, online redo log files. And then increase availability at the instance level. So in a clustered environment, you are sharing data files, but you'll have multiple instances or multiple SGAs. So when we talk about things like a 3-node cluster or a 4-node cluster, we will have 3 separate SGAs managed independently, or 4 separate SGAs managed independently. In the event that one of these SGAs or one of these instances fails, the database in and of itself will still be available. So a cluster is the ability to cluster our instances together to prevent a single instance failure. So in a traditional single instance environment, we have one instance and one database. If that instance fails, the database fails. In a clustered environment, if you have 3 instances on 3 separate physical machines, if one of those physical machines fails, the database is still available. So let's talk about what is a real application cluster, specifically as it pertains to Oracle 12c. We will have multiple instances, which would be multiple independent SGAs. Each individual instance or SGA would reside on its own individual server. We will have a series of shared disk devices. In Oracle 12c, you must use ASM. So the grid infrastructure is a requirement in Oracle 12c. So each individual node would have its own individual instance. In Oracle 12c, we can have a 2-node rack, we can have a 3-node rack, we can even have a single node rack, which is also referred to as rack 1 node. So for each individual server, also referred to as node, they would have its own individual instance. Keep in mind, you do not want to have multiple instances on an individual server. Each individual instance will have its own set of memory, so its own SGA. Those SGAs may be different across nodes. So I could have a 3-node rack. Node 1 could have a 10 gig SGA. Node 2 could have a 12 gig SGA, and Node 3 could have a 14 gig SGA, or however you want to configure it. Please keep in mind that each individual node will have its own set of online redo logs as well as its own set of archive logs. Within each individual instance, there will be certain database parameters that have to be configured the same, certain database parameters that have to be configured differently, and a series that do not matter, and we will get to those later on. When we talk about Oracle 12c, we're also referring to what's called grid computing. This is also part of Oracle's 12c grid infrastructure architecture. This provides things like high availability, zero downtime, and you will also hear the term HAA. HAA stands for High Availability Architecture, which would include things like Oracle RAC as well as Oracle Data Guard. So when we look at an overall racked environment, RAC obviously stands for Real Application Clusters. Why would we do this? Well, it does provide us better performance. Better performance is really defined as better throughput. So when we say better throughput, this means if I had a single instance, so just not even a racked environment, just a single instance that could handle 50 users, and then the application now suddenly has 75 users, that instance would be taxed. In a racked environment, if we have a 2-node rack, each individual instance handles 50 users. This means we can handle up to 100 users. So therefore, our 75 would not be a problem. So when we talk about better performance, we're really referring to as better throughput. It also gives us high availability. We no longer have a single point of failure. If we're in a 2-node rack and one of the nodes goes away, the database in and of itself is still available. We could fix the problem and then restart that specific node. It is also fault tolerant. The Oracle 12c Flex ASM architecture means that you are no longer required to have an ASM instance on each individual node within the racked environment. So why do you use rack? What is the value of using rack? Well, we support little or zero downtime. So again, we no longer have a single point of failure. We will support what's called TAF, or Transaction Application Failover. What this means is in the event that I have an application up and running on a specific node, if that node goes away, the application would then be transferred over to the surviving node. It can also provide us additional processing power, especially if we parallelize our queries. So if you have a long query running against a table that has 5 billion records, you can split that query across all of the nodes within the rack. So why do you use rack? Because it's going to give us 100% availability. So those applications that require no downtime, mission critical, where lives are at stake, or millions of dollars per second are at stake, we want to use a rack environment to guarantee the system is up and running. Or if the application itself is a very resource-intensive application, if it's an IRS application, a healthcare application, a HIPAA application. And finally, if our end users demand performance, so they demand better throughput. Also, it makes our applications scalable. So as the application grows, all we have to do is add another node to the racked environment. So what does the racked environment need? What type of software, what type of hardware does an Oracle cluster need? Well, first of all, you would need multiple nodes, unless of course you're doing rack node 1. If you're providing rack node 1, you only need to have one node. However, typically you're going to have multiple nodes in the rack environment. Each individual node will have their own SGA. Each individual SGA needs to have a significant amount of memory. Overall, rack needs about 3 things: a lot of disk space, a lot of memory, and a fast network. What OS does the rack operate on? Well, it pretty much can operate on any operating system, whether it's a Windows-based operating system or a Linux-based operating system. If it's a Linux-based or *UX environment, we prefer to be a Linux 5.5 or greater. If it is a Windows operating system, we prefer it to be a Windows Server class machine, something like Windows 2008 R2 or greater. But again, it can be on a Linux, Unix, Sun, or Windows-based server. So pretty much any operating system out there, Oracle 12c Rack will run on. So for those applications that require high availability or virtually zero downtime, they have high performance requirements, then you would want to introduce the racked environment. The racked environment can sit on top of Linux, Unix, and/or Windows. So the first thing you would look at is, does this application have a requirement to be up and running 24/7? If it does, rack would be a serious consideration for you. Keep in mind, from an Oracle perspective, you would need to have additional licenses for the rack if you're using Enterprise Edition. If you're using Oracle Standard Edition, a 2-node rack does come with Oracle Standard Edition. Rack is not available with Oracle's Express Edition. Some of the other things that you would take a look at for rack is the disk space. Please keep in mind that each individual instance will have their own set of redo logs as well as their own set of archive logs, and these will operate independently. These are also referred to as threads. Each individual instance is going to be referred to a specific thread. So if you have node 1, you would have thread 1. If you had node 2, thread 2, and node 3, thread 3, etc., etc. A rack environment will share data files as well as control files, but each individual instance has their own copy of redo logs as well as archive logs. Also, please keep in mind that each individual node will have its own instance. You will choose rack because the business demands it, the application demands it, or you must meet some sort of regulatory requirement, whether that's HIPAA, PCI, Sarbanes-Oxley. Thank you for attending.